Welcome back to Math 104. According to the National Center for Health Statistics, 22.2 million Americans had asthma in 2005, out of a population at the time of 291 million. Of these 22.2 million, 6.5 million children and 15.7 million adults had asthma in 2005. So here's our experiment. Select an American at random, test for asthma, and find out the person's age. Let's consider two events. A, the person has asthma, and M, the person is a minor, that is, under 18 years old. Here are the data in millions arranged in a two-way frequency table. This is going to be a very useful way of organizing information. This 6.5 means 6.5 million people. Those are the ones who are under 18 and had asthma. Since this row represents the event M, and this column represents the event A, this entry in the table, the 6.5, represents the number of outcomes in the event A intersect M, or M intersect A. The number of outcomes, that is, the number of people in the event A and also in the event M, equals 6.5 million. Similarly, these 15.7 million are in the event A, and they are in the event M complement. They are not minors. They have asthma, and they are not minors. These 66.6 million people are the ones in the event A complement. They did not have asthma, but in the event M, they are minors. And these 202.5 million are in the event A complement intersect M complement. They didn't have asthma, and they're not over 18, so they're in A complement and also in M complement. This gives a total of 22.2 million people who had asthma, and therefore 269.1 million who didn't have asthma. We also see here that 73 million were minors, and 218 million were not minors. They were adults. That makes for a total of 291 million. Another useful way of expressing the same information is in terms of probabilities. What is the probability that a randomly selected person had asthma and was under 18, so the probability of A intersect M equals 0.022. This is 6.5 million divided by 291 million. 6.5 million people in the event A intersect M out of 291 million total in the sample space. The experiment is to draw randomly from these 291 million people, so that's the number we're dividing by to find the probability. Similarly, the probability of not having asthma and being a minor equals 0.229. That came from computing this 66.6 million, again out of the 291 million total. Overall, the probability that a randomly selected person was a minor back in 2005 was 0.251. Another way of saying this is in terms of percentages. 2.2% of the total population were minors with asthma. 22.9% of the total population were minors without asthma, and 25.1% of the total population were minors. Similarly, 5.4% of the total population were adults with asthma, 69.5% were adults without asthma, and 74.9% of the total population were adults. The sum of these two numbers. And finally, this number down here, the column sum for the asthma column, shows that 7.6% of the population had asthma. It breaks down as so many minors and so many adults. The sum of these two probabilities equals 0.076. Then 92.4% total, 92.4% of the whole population did not have asthma. Every probability in this table is in relation to the total population of the United States in 2005. Finally, we come to our most useful way of representing this information, which is in terms of an ideal data set of a nice round number of people. Let's look at an ideal data set of 1,000 people. Where did I come up with the idea of 1,000 people? Every probability is a decimal extending no farther than the third decimal place. That means that if I take any one of these numbers and multiply it by 1,000, I will get a whole number, which is what we need for an ideal data set. That means that in a truly representative group of 1,000 people, that's what ideal data set means, in a truly perfectly representative group of 1,000 people, what concrete number of them had asthma and were minors? Exactly 22 of them. 0.022 times 1,000 equals 22. How many people out of 1,000 didn't have asthma? That's 229. The probability times the total number in the dataset. The total under 18, we can either add these up to get 251, or we could just take this total probability, 0.251 times 1,000. By the same thinking, we'll get 54 here, we'll get 695 adults who did not have asthma, and 749 adults total. By summing this column, we see that there were 76 people in a truly representative group of 1,000 who had asthma, whether they were minors or adults. And finally, there were 924 people total who did not have asthma. Doing some work to the given information, in order to represent it as an ideal dataset of a nice round number of people, will turn out to be incredibly useful. Let's use it now to find the probability that a randomly selected person with asthma is a minor. Let's write this probability in P notation. So let's interpret this. A randomly selected person with asthma. That's whom we're selecting randomly. So we're already specifying that the person has asthma. We are selecting from among the people who have asthma. That means we're selecting from these 76 people. 22 out of those 76 are minors drawn from this group. This equals a conditional probability because we are zooming in on the people with asthma before we select. This is the probability of M given A. We have to be very careful with the wording of each of these questions to sort out whether the probability is conditional or unconditional. Here it was conditional. Now let's find the probability that a randomly selected person is a minor with asthma. Let's read the wording very carefully. Randomly selected person. Not randomly selected person with asthma, not randomly selected person under the age of 18, but just randomly selected person. So the chance that a randomly selected person is a minor with asthma, that means both a minor and having asthma. This is the probability, this is an unconditional probability, the probability of A intersect M, and that's 22 out of 1,000. This probability is unconditional because we are considering a randomly selected person from the entire population. Find the probability that a randomly selected minor has asthma. Now we're only selecting from among minors. We are trying to find the probability of A given M. Now we're zooming in on the first row. To answer our first question, we zoomed in on the first column, but now we are zooming in on the M row. That's because we're conditioning on M. So we zoom in on the M row, we focus on the M row, and see that the probability of this event equals 22, not out of 1,000, but out of 251. Thus the last three probabilities have all had 22 as their numerator, but they're all different probabilities. We can condition on A, we could condition on M, or we could not condition at all. Before going on to the next video, answer the following questions. Is having asthma independent of being a minor? And find the probability that a randomly selected person who doesn't have asthma is an adult.